Hi, today we are going to look at why giant cargo ships have flat bottom. Picture a modern cargo ship, a steel giant weighing hundreds of thousands of tons, stacked with enough containers to build a small city. You would probably assume that below the waterline, the beast has a sharp, deep V-shaped hull to slice through the ocean. Well, prepare to be surprised. Underneath, these maritime giants are almost completely flat, and it feels totally continuity. How does a flat sheet of steel carrying a skyscraper worth of weight not just tip over it for the storm? When we picture fast boats, we picture V-hulls. Speedboats use sharp, pointed bottoms to cut through waves at high speed. But a cargo ship isn't trying to win a race, it's trying to move mountains. A deep V-hull should need a deep draft, sitting far down in the water like a dagger. That would make many of the world's ports impossible to enter safely. A flat bottom gives the opposite, a shallow draft. Instead of reaching deeper, the ship spreads its weight and its buoyancy across a much wider footprint. But it keeps upright. But it stops it from flipping. Press down on the edge of the flat plank floating in the bathtub and flips it instantly. So why does a giant ship? The answer is principle called form stability. A ship is locked in constant, invisible tug of war. Gravity pushes down through its center of gravity and buoyancy pushing up because the hull is so wide that upward push is spread across enormous areas. When a wave rolls the ship to the side, the boat hulls shift the center of buoyancy, creating a restoring force that automatically pushes the ship back to level. But from stability alone isn't enough. An empty ship rides high and becomes unstable if its weight isn't balanced. In the 1700s, sailors sold this by loading rocks and irons into the bottom the hull when cargo was light. Today's ship uses brilliant modern version ballast water. When the ship drops off its container, it pumps millions of gallons of